Once again, good morning, everybody. Welcome to Academy, the place for mathematics and science. Dear students, in the last class, we were discussing the chapter light, reflection, and refraction. So, in this chapter, we were discussing the concept called formation of image by a concave mirror, and we started describing the characteristics of images as well, that is nature, size, and position of the image when the object is placed in front of the concave mirror. But these characteristics depend on the position of the object in front of the mirror. Then what are the places we may go for placing the object in front of a mirror? One is between P and F, second one at F, third one between C and F, fourth one at C, fifth one beyond C, and another one is at infinity. So among these, I think we have discussed the first three. Okay, now you just go for writing today's date. Let me write here name of the chapter. Chapter 2 in physics that we are covering. The name of the chapter is light, reflection, and refraction. Today's date 26. Write in a notebook as well. It is 26/7/2021. Before going to discuss the characteristics of image formed by a concave mirror when the object is placed at C, just we shall recall the other positions of the object where we got the images. Now you don't go for writing anything. What do you call this horizontal line with respect to mirror? It is principal axis. Here I am going to mark some points. And if you consider this point as pole P, what is this? This point. It is principal focus. Another point, center of curvature. What about this? It is aperture, that is reflecting surface of the mirror. Now tell me, what type of mirror it is? It is concave mirror. So you all know that object may be placed in front of the mirror between P and F, that is pole of the mirror and principal focus. Where the image is formed? Image is formed behind the mirror or inside the mirror. Whether it is upright or inverted, it is upright. Upright image is nothing but erect image. So we consider object as AB and the image as A dash, B dash. Then what is the nature of the image? It is virtual and erect. Nature is virtual and erect. Size, magnified, that is bigger than the object, taller than the object, larger than the object. So in general we use the word magnified. So magnified image is formed. Then position, you have already told, it is formed behind the mirror, right? Shashank Kemachar, got it? Okay. Next. Now let us go for placing the object at F. Where the image is formed? Where the image is formed when the object is placed at F? Image is formed at infinite distance in front of the mirror. That is on the same side of the object, right? Whether this image form is upright or upside down, which is nothing but inverted image. Here, image is formed here. I'll just go for changing the name. This is PQ. Then this will be P dot Q dot. When the object is placed at principal focus, image is formed at infinite distance in front of the mirror. Then what is the nature of the image? Real and
magnified. Real and virtual.
okay. The reason is this image can be caught on the screen. So it is real, and this image is formed below the principal axis.
Real and inverted.
Inverted. Nature is real and inverted. Size
Highly magnitude.
magnified, not bigger than the object. Next, position, just you told that at infinity in front of the mirror. Got it? Spurti BR. Got it? Okay, very good. Next, what is the other position? Between
In F and G.
center of curvature and principal focus. Here, let me draw the object and I call it as ML. Where the image is formed?
Front of the mirror,
Yeah.
beyond C.
Beyond C. That is after C. Here. This is M dash, N dash. What is the nature of the image form?
Real and inverted.
Size
Real and inverted.
magnified. That is
Bigger
Magnified.
position beyond
Beyond
C.
C, in front of the mirror.
Got it? So this much we had discussed in the last class. Now let's go for discussing again the characteristics of image when the object is placed at C as well as beyond C. Including that, we shall go for by taking the object at infinity also. Yes. Now let's move on to fourth position of the object in front of the concave mirror. Right. Fourth one. Right. When the object is placed at C. When the object is placed at C, that is center of curvature. Just recall the definition of center of curvature. The center of imaginary sphere of which mirror is a part. It is center of curvature. Protractor. First you go for drawing a straight line. First draw a straight line. Then after that, go on marking for every unit distances. For comfortable distance, you may go for taking 2 centimeter. Now, let me go for taking, go on marking for every 2 centimeter. 2, 4, 6, 8. Now, you may mark this point as I am taking the second point. It is C, which represents center of curvature, and this is F, and is P. Third point is P. Next, you may use either protractor or compasses to draw an arc which represents the mirror. Here. So take compasses with C as center and CP as radius. Draw an arc. Okay. Next. So as it is a concave mirror, we have to show the reflecting surface which is bulged inward or outward. Inward. Non-reflecting surface is bulged outward. Overall. Now you tell where the object should be placed. At C. So again, take scale and draw perpendicular line. What is the general height we are taking? 1 centimeter. Yeah, I'm taking 1 centimeter. Exactly 1 centimeter. Next. You may name this as AB. Over. Next. What is the first ray that we have to draw? Yes, a ray of light coming from the object incident on the mirror parallel to the principal axis. Take scale and pencil and draw a line parallel to principal axis from A. Over. Then what happens when this ray incident on the mirror?
It passes through focus.
Passes through focus.
Passes through
Reflection
focus
passes through
after
focus.
the reflection. So now let me draw the reflected light. You have to show the direction. Then what is the second ray to be taken?
Ray passing from focus.
Yes, a ray of light coming from the object passes through the focus, then it incident on the mirror. Here, from A. You can draw the ray like this. Then what happens after the reflection? Yes.
It becomes parallel to principal.
Parallel to principal
Parallel
axis.
to the principal axis.
Principal axis. Should not be any difference in the measurement. Even if it is a difference of 1 or 2 millimeter, you won't get it properly. Now draw the reflected light ray, which is parallel to the principal axis. And both the reflected rays will intersect at a point. Mark this. From that point, draw a perpendicular line to the principal axis. Check whether you got like this. A dash, B dash. That is the image. Over. Finished now? Now, let us write the characteristics. First, it is nature. Can it be caught on the screen? Yes.
Yes, sir.
Therefore, it is real image. And we know that this image is formed below the principal axis. Therefore, it is
Got it.
upside down. Hence you can call this image as
Inverted.
inverted. So nature is real and inverted. Next, second point. Size.
Same as the object.
Size of just go for comparing the size of the image and size of the object. Here it is 7 point. No, I have taken exactly 8 centimeter. Image form is also 8 centimeter. So size of the image is equal to size of the object. Size equal to object. Position. Where is the position?
Formed at C.
At center of curvature.
It is image is formed at center of curvature in front of the mirror. Right. Position. At C. In front of mirror. Finished up? Finished. Come and sit over there. Come to second bench here. Okay. Look here. Just one simple question. Suppose focal length of a mirror is 20 centimeter. Focal length is 20 centimeter. Could you tell where the object is placed in this case? At what
40
distance?
centimeter.
40 centimeter.
40
40
centimeter.
40
centimeter.
centimeter.
Look at focal length is 20. From P to F 20. F to C will also be 20. 20 plus 20, it is 40. Object is placed at 40 centimeter. Then where is the image from? At what distance image is formed?
40 centimeter.
In 40 centimeter, image is formed at a distance of 40 centimeter in front of the mirror. Got it? Next, we'll move on to fifth position. Fifth one is the object should be placed beyond C. Right. When the object is placed, beyond C, when the object is placed beyond C, yes, we are very familiar with the steps to be followed to draw the ray diagram. Follow the same. First, you draw a straight line. Draw a straight line and go on marking for every unit distance. That is unit, you can take that unit distance as 2 centimeter. Here, 2 centimeter. Next, 4 centimeter. And I'm marking third point at 6 centimeter. Next, 8 centimeter. Then 10 centimeter. Yeah. Let us mark from here. This was the first point. Let us call this point as P. P represents pole of the mirror. Next, second point. This is represented by F, where F indicates principal focus. Next point is C. This is center of curvature. Next, take compasses or protractor. If you are using compasses with C as center, CP as radius, draw an arc with CA center, CP as radius, draw an arc which represents the reflecting surface of the concave mirror. As we have to show the concave mirror, let us shade the non-reflecting surface which is bulged outward. Yes. Show this shaded part which represents non-reflecting surface. Now let us go for placing the object where it should be placed beyond C. Okay. If I consider this as F, this point can be considered as 2F. The reason is the distance from P to F is equal to F to C. Then from P to C, it will be 2F. Then what about this point? 3F. Next point will be 4F, like this. Then we are placing the object beyond C means you may place between 2F and 3F or 3F and 4F, 4F and 5F, wherever. But it should be after C. Now, take scale and pencil. Then draw a perpendicular line which represents the object. Let the height of the object be 1 centimeter. You may show this object just after C or else even with more distance also. No rule that you should place the object here only. You may place either at this point, this, or this. And name it as AB. Just let us follow the first ray. What is the first ray? The ray which is incident parallel to the principal axis here. Draw a line parallel to the principal axis. This line represents a ray of light coming from the object. As it incident on the reflecting surface of the mirror, it gets reflected. What happens after the reflection?
Meets at
Passes through focus. Yeah. Draw that. Again, I am reminding, without fail, you have to show the direction. If you do not represent it, this won't be considered for the marks. Next. What is the second ray?
Ray of light passing through focus.
Right.
Ray of light coming from the object passes through the focus, then it incident on the mirror. Wait, don't go for drawing. Then
It's a ray of light passing through center of curvature.
beyond C, can we go for taking a ray of light coming from the object passes through the center of curvature and incident on the mirror?
Yes,
Can
sir.
be taken. That ray can also be taken. Not only that, another ray of light coming from the object incident exactly at 4, then it gets reflected. The reflected ray will make an equal angle with the principal axis, right? Any of these 3 rays can be taken. All will be same only. Don't draw, just observe here. If I take a ray of light coming from the object passes through the center of curvature, it will intersect here, right? Even if you take a ray of light coming from the object passes through focus, then it incident. Please don't draw, first observe. And we all know that this ray gets reflected. Reflected ray will be parallel to principal axis. Same point only. Yes, now you may draw. You may draw the light ray passes through the focus or passes through the center of curvature or incident at pole. Any of the three, the remaining three rays can be shown. Over. Ikra Nazni. Over. Yes, very good. Then you can observe a point of intersection of both the reflected light rays. From that point, draw the perpendicular. You may call it as A dash, B dash, which is the image of the object. Now let us go for writing the characteristics. Right. Characteristics of image. First one. Nature.
Real and inverted.
Real and inverted. It is real because image can be caught on the screen. And is inverted because the image is upside down. It is found below the principal axis. So here I'm going real and inverted. Real and inverted. Size.
Diminished.
Smaller
It
than
is.
the
Just compare the size of the image with the size of the object.
Smaller than the
Coming
image.
on that, it is smaller than the object.
Diminished, sir.
We have, very good. We have scientific word to represent the smaller size. It is diminished, right? D-I-M-I-N-I-S-H-E-D. Size is diminished. That is smaller than the object. Then position.
Between C and F.
Between C and F in front of the mirror.
Very good. Between C and F in front of the mirror. Right. Between C and F in front of the mirror. C and F in front of the mirror. Overall. Again, one simple question with respect to this one. Assume that focal length of the mirror is, this concave mirror is 20 centimeter. Where the object is placed?
60
At
centimeters.
60, above 40, sir.
Is placed after 40 centimeter. Focal length it is 20 up to here 20 plus 20 40. Object is placed after 20 centimeter. Then at what distance image is formed? You cannot tell the exact distance here. Instead,
Between
you
40
can
and
tell the
20.
range. Yes, it is image is formed between the distance of 20 centimeter and 40 centimeter. C and F, 40 and 20. Image is formed with a range of 40 centimeter and 20 centimeter. Followed? Yes. Now we have another last position of the object in front of a concave mirror. It is at infinity. Right. Sixth one. Sixth one. When the object is placed at infinity. Sixth one. When the object is placed, when the object is placed at infinity. Again, same drawing only. First draw a straight line which represents the principal axis and go on marking for every unit distances is 2 centimeter, mark for 4 centimeter, then 6 centimeter and 8 centimeter. Mark the first point as P, second point as F, third point as C. As we are going to place the object at infinite distance, from here you can show the dotted line. Then take either protractor or compasses. If you are taking the compasses with the C as center and CP as radius, draw an arc which represents the reflecting surface of the mirror. As it is concave, the non-reflecting surface is bulged outward. Can be shown like this. That is, reflecting surface is bulged inward. Now, let us go for placing the object at infinite distance. You are not going to place, but you can get the image of the object which is at infinite distance. Let me distance. Suppose you are standing in the open field, you find a tree which is far from you, that its image can be focused. So, hence, I am going to take the object here, which is at infinite distance. Call it as AB. We know that from the object, plenty of rays of light will be coming. Some rays will incident parallel to the principal axis. Some rays passes through the principal focus. Some rays passes through center of curvature. Here, we are going to take only two rays to draw the ray diagram to represent the formation of image. I'm going to choose the two rays coming from the object. One passes through the focus and another one passes through the center of curvature. Yes. You find it difficult because the object is placed at infinite distance. Just I go for taking the two rays. This is first ray which passes through focus, and after incidenting on the reflecting surface, this ray get reflected and the reflected ray is parallel to principal axis. This is first ray. And the second ray, a ray of light coming from the object, passes through the center of curvature. Many rays will pass through the center of curvature, but I am going to take one ray passes through the center of curvature parallel to the first ray. Here I am taking the parallel beam of light. In this parallel beam of light, one ray passes through the focus and another ray passes through center of curvature. You all know that this ray will incident on the mirror perpendicularly, that is normally. Then what will be the angle of incidence?
90 degree.
Angle of
0 degree.
incidence,
90.
0.
it is 0 degree, right? Then what is the angle at which light incident on the mirror?
90
90
degree.
Then what will be the angle of reflection? It is 0 degree.
0 degree.
So if it is 0 degree, the reflected ray moves along the path of the incident ray. Followed? Sanjana, is it okay? Sanjana, okay, right. Very good.
Sir, repeat, sir.
One second. See that here we have placed the object at infinite distance. Plenty of rays of light will be coming from the object. To show that through the ray diagram, I am going to choose two rays of light which are parallel to each other. Among these two, one passes through the focus and another passes through the center of curvature, then incident on the mirror. The ray of light passing through the focus and incident on the mirror get reflected, then the reflected ray is parallel to the principal axis. And another ray of light passes through the center of curvature, incident on the mirror, perpendicular to its surface. Therefore, angle of incidence will be 0. As a result of it, angle of reflection will also be 0. This reflected ray moves along the path of the incident and it has intersected at this point. Now let us draw a perpendicular and name it as A dash, B dash. Now you tell, what is the nature of the image?
Real and inverted.
Real and inverted. Right. It is real and inverted. Next. Nature size. Yes, it is very smaller than the object. Hence, you can go for using the words highly diminished. Right. It is highly diminished. Where the image is found? At focus.
Focus in front of the mirror.
Yes.
At focus.
At focus in front of the mirror. At F. In front of the mirror. Finished up?
Yes,
Now
sir.
if the focal length of the mirror is 20 centimeter and you are going to get the focus of or you are going to catch the image of the object which is at infinite distance. Could you tell at what distance image is found?
20
20
meters.
20 centimeter.
Only, sir.
Right? Finished up? Vandana, Drupadesh, Ashutosh, Suraj, Nitya, VD, Ritu, finished. Okay. Just observe it. Don't go for writing anything. What does this straight line indicate? Principal axis.
Principal axis.
This first point, sorry. Aperture.
Aperture.
What type of mirror?
Concave.
Concave mirror. This is
Pole.
yes. Midpoint of the mirror is known as
Pole.
mirror. What is this? Principal
Principal focus.
The point on the principal axis where the rays of light actually meet or appear to meet after the reflection from the mirror. It is principal focus. This is
Center of curvature.
Center of curvature.
Center of curvature. What do you call the distance from P to F?
Focal length.
Focal length.
P to C.
2F.
Radius. Radius.
And radius of
What
curvature.
Radius.
Radius of
Radius of
curvature.
curvature and focal length. R equal to 2F or F equal to R by 2. Now, observe. First, we place the object in front of the mirror between P and F. Next, We place the object at F. Next, we place the object
Between
beyond
C and F.
F and C. Then we place the object
At C.
at C. Next, we place the object
Beyond C.
beyond C.
Beyond
Right?
C.
Now you tell. When the object was placed between P and F, where the image was formed,
Behind the mirror.
Behind the mirror.
And the
Behind
mirror.
the mirror.
Behind the mirror.
upright or upside down image,
Upright, sir.
Upright.
Right.
and it is also magnified. That is bigger than the object. When the object is placed at F, where the image is formed,
At infinity, sir.
At infinity solution.
infinity. At infinity, it is. Then diminished or magnified or highly magnified,
Highly magnified.
Highly magnified.
and it is inverted image. Next, when the object is placed between C and F, where the image was formed,
Behind C, in front of the mirror.
Beyond the mirror.
beyond,
Beyond C.
C,
Beyond
in front of the mirror.
yes, beyond C, in front of the mirror, upright or inverted,
Inverted.
Inverted.
magnified or diminished,
Magnified.
Next, when the object is placed at C, where the image was formed,
At the
C.
infinity
only
cell
in
of the
front
mirror.
mirror. Erect or inverted? Inverted. What
Inverted.
about
Inverted.
same as the object,
Diminished.
not diminished. It is same as the object. Next. In the next position, object is placed beyond C, where the image was formed.
Between C and
Between
and
C and
in front of the mirror.
Yeah. Erect or inverted?
Inverted.
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 Diminished or magnified?
Diminished, sir.
Diminished.
Diminished. Right? And when the object was placed at infinity, image was formed at F and it was highly
diminished.
Point size.
You just observe it. Here, these arrow marks, upright arrow marks indicate the objects, right? From here. Now, the object is being taken out or taking away from the mirror. Once you observe, object is taking away from the mirror. Image, these are the images. Okay, these are inverted images. Inverted, the distance of the inverted images increasing or decreasing? Decreasing or
Decreasing.
Decreasing.
See that as the object takes away from the mirror, then image will be closer to the mirror, and all are inverted only, except one case. In only first case, when the object is placed between P and F, in that only virtual and erect image is formed. In all other positions, that is at F and even after beyond F, in all other cases, image will be real and inverted. Got it? Look here. Assume that these are the objects and this is the image. When the object is placed between P and F, image will be upright. Now, object is to be taken away. Object is to be taken away from the mirror. Then image will be inverted. When it is very close, it is upright. When it crosses or when it is at F or crosses F, then it will be inverted. Clear?
Yes, sir.
Yes, sir.
Now, just one simple question. Focal length of the mirror is 20 centimeter. Focal length of the mirror is 20 centimeter. To get highly diminished image, where the object should be placed?
At infinity. At infinity.
At infinity. Actually, at infinity, we get a point image. Point image ಬರುತ್ತೆ. ನಾವೇನಾದ್ರೂ object ನ infinite distance ಅಲ್ಲಿ place ಮಾಡಿದ್ರೆ, we get the image at focus, and that will be a point image. And for usually for highly diminished will be used. Highly diminished will be used when the object is placed beyond C. Got it? And to get the image beyond C, where the object should be placed?
Between C and F.
Between C and F.
C and F.
C and F. Got it? Then, to get the highly magnified image, where the object should be placed?
At F.
F.
At F in front of the mirror, because image is found at infinite distance with a greater height. To get magnified erect image, where the object should be placed?
Between P and F.
P and F.
Okay. To get magnified and erect, that is upright image, object should be placed between P and F. To get the image whose size is equal to size of the object, where the object is
At
placed?
C.
At C.
Center of curvature.
Center of curvature.
At center of curvature. When the object is at C, size of the image is equal to size of the object. Got it?
Yes, sir.
Now, we are moving to the next part of this chapter, that is formation of the image by convex mirror. So, in that, just I'll go for taking any two ray diagram. They are enough. Almost the same. You'll come to know that. Now you take, before going to that, one more question. What will be the size of the image when the object is taken away from the mirror, concave mirror?
Diminished.
It gets diminished. It will go on decreasing as the object. See, this is the mirror, concave mirror. I am moving away from this concave mirror. Then my size will go on
Decreasing.
Decrease. Yes, next side heading. Side heading. Formation of image by convex mirror. Formation of image by convex mirror. Formation of image by convex mirror. And describing the characteristics of image. Describing the characteristics of image through ray diagrams. So formation of image by either concave or convex through ray diagram, it is 10% question in the examination. So don't go for neglecting. And finished done? Yeah. Have you all finished? Ruchika, finished? Vijeta? Varsha HR, finished. Aryan Shetty, Mohammad Faisal, have you finished? Okay. Now just observe here. Yeah. This is a straight line. What does it represent with respect to mirror? It is
Principal axis.
principal axis.
Principal axis.
This is aperture.
Arch.
Now, if the reflecting surface is bulged outward, what it is called?
Convex.
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 Here I am showing the non-reflecting surface. Then, what is this?
Cone.
Then this is the focus.
Focus.
Focus of convex mirror and
Center of curvature.
the center of
Center
curvature.
of
Center of
curvature.
curvature.
Yeah, where the object should be placed. Should we place the object here? Here? No, you cannot.
No, sir.
At infinity, sir.
At infinity. No. Observe here. If you want to get the image
After P, sir.
of the object should be placed in front of the reflecting surface. Here, right side is reflecting surface. You cannot place the object on the left side.
Yes, sir.
Place on got it? Then how do you say object is placed at F or between P and F or beyond C at C?
Sir, in front of the mirror and at infinity.
Means you are telling that we have to show the formation of the image only when the object is placed at infinity. Then what do you say about F, 2F or else between F and C or at C beyond C?
Sir, they are in behind the mirror. They appear to meet, sir.
No, my question is, here we have to show the formation of image by convex mirror when the object is placed at C and the Kurta. How do you go for marking? Whether you go for placing the object here? No.
No,
No,
sir.
sir.
Here, this line is to be extended. And P there, and this is F. This is F for the third one. Got it? Next, this is C. That is distance from P to C on the left side is equal to distance from P to C on the right side as well. Now you may go for placing the object at F or between C and F or beyond C or at C. But in all cases, now I am going to place the object beyond F. You should also draw with me. First, right. When the object is placed, between P, that is pole of the mirror, and infinity. Wherever we want, we can place it. Now, go for drawing a straight line. Draw a straight line. And go on marking for unit distances from this point. Let the unit distance be 2 centimeter. Here, 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter. Then you may continue also. 10 centimeter. You call this point as C. This as F, principal focus of convex. This is P. This is P. For our reference, we are marking these points as F. ಎರಡು ಒಂದೇ ರೀತಿ ಆಗ್ಬಿಡುತ್ತಲ್ವಾ ಅದಕ್ಕೆ ಸ್ವಲ್ಪ very good. One modification F dash and this will be C dash ಅಂತ ತಗೊಳ್ಳೋಣ. Next, here with the C as center and CP as radius, draw an arc. Next, here as it is convex mirror, the reflecting surface should be bulged outward. This is reflecting surface. So non-reflecting surface, let us represent it with these shaded lines. Here, the object can be placed wherever you want between P and F. So here, I am taking the object at this distance. What is the height of the object? 1 centimeter. Yes. And you may name this as AB. AB. Next. Tell that. What is the first ray? Parallel to.
Principal axis passes through focus.
Principal axis. A ray of light coming from the object incident on the mirror parallel to the principal axis. So here I go. Don't draw like this because light is coming from right side. So let us draw in this. Is it parallel? Parallel is not. What happens to this light ray after the reflection?
It passes through focus.
Passes through focus.
Appears as it is diverging as it is coming from the focus or just observe here. From here I'm putting dotted line, then from here dark line. Without fail.
Appears to pass.
Reflect. This is incident ray and this is reflected. Next, second ray. Second ray is the ray of light coming from the object incident on the mirror in the direction of
Center of curvature.
center of curvature. Please look at the board. Mukta, look here. This is the direction of center of curvature. Here, this is the light ray coming. It is with the direction of center of curvature. And we all know that this ray incident on the mirror normally, right? That is perpendicular. Then what is the angle of reflection?
0 degree. 0.
0 degree. So if it is 0 degree, then the reflected ray moves along the path of incident. And this ray should be extended on the other side of the mirror. Then both will intersect at this point. I'm marking the point. This is the point. From this point, let us draw a perpendicular. You may call it as A dash, B dash. Now let us go for describing the characteristics. Here are characteristics. Then, what is the nature of the image form? Is it possible
Virtual
to
and
catch
direct.
the image on the screen?
No, sir.
Yes, sir.
It is behind
No.
the mirror.
Virtual and
Nishka,
virtual
Nishka?
and image.
is it possible to catch the image? No. So it is virtual or real? It is virtual image.
Virtual, sir.
Whether it is upright or upside down.
Upright, sir.
Upright.
Upright, sir.
It is
Upright.
direct image. Nature is virtual and erect. Nature is virtual and erect. Size. Compare the size of the image to the object. What
Diminished.
is it? Diminished. Smaller than the object. Size of the image is smaller than the object, AB. Therefore, you can write it is diminished. Next, position,
Sir, highly diminished.
where the image is formed.
Sir, we can say
Behind the mirror.
Sir.
Left behind the mirror.
P and F. Between P and F, behind the mirror or inside the mirror. Right. Between P and F, inside or behind the mirror.
Sir, size is highly diminished notes.
Huh?
Size is highly diminished notes.
Highly diminished. So to know that, you have to take it at a different positions also. Let us check it out.
At infinity, sir.
Wait. I'm bringing the object closer to the mirror. Here. Keep positioning it. Hope that you are able to see the green light.
Yes, sir.
Yes. First ray is common. Light ray incident parallel to the principal axis get reflected, and this reflected ray, when it is extended, it appears as if it is meeting at F. And another ray of light coming from the object, incident on the mirror in the direction of center of curvature. Now, if you notice that these rays will intersect at this point. Got it? Can you all see?
Yes, sir.
Yes, sir.
Observe this green line. Now you tell that image is smaller than the object or bigger than the object?
Smaller than the
Smaller
object.
Smaller than the object.
But compare the size of the first image. Compare with the size of the first image.
It
What
is
is
smaller.
it?
Bigger,
It
sir.
is bigger than the
Bigger than
first one. Alva?
Yes,
But
sir.
under what condition? The
When the
object
object
is
is
brought
closer to the mirror.
mirror. Next. I'll take another one. Just look here. I'm taking the object. I'm taking the object beyond C. That is much distance than the first two objects. First ray is common, no change at all. Second ray, it will be in the direction of center of curvature. Observe the ray of light coming from the object which is placed beyond C. It incident on the mirror in the direction of in the direction of center of curvature. Observe. These two rays, see this black color ray, will intersect at this point. This is image. Got it? Are you following?
Yes, sir.
You can, what will be the size of the image as the object is taken away from the mirror?
Highly diminished.
Also,
Highly diminished.
First, second, third. Here, first, second, third. As the object is taken away from the mirror, the size of the image will go on decreasing.
Decreasing.
Got it?
Highly
What about
diminished.
in case of concave mirror?
It goes on increasing.
Increase.
Size. There also it was same, no? As the object was taken away from the mirror, the size was gone, decreasing. They only could have. So here also the same, but the difference what you can notice is in case of concave, adun recall madkoli. In case
We
of
got
concave,
real and real images.
very good. When the object is taken away from the mirror after F, it was inverted. All the
Inverted.
images were inverted. But you know, here object is taken away from the mirror and image will go on decreasing, but size, image will go on decreasing, and also all the images are upright only. Erect irutte. Clear up?
Yes,
Yes,
sir.
sir.
Look here. Now let me show you the image form. Assume that this is the mirror. This is the mirror. Now object is there in front of the mirror. Now assume that image is formed. Object is taken away from the mirror. Object is taken away from the mirror. Then look here. The size will go on decreasing and it is erect only. And as it is brought closer, the size will go on increasing. Again, it is erect. You can say that this mirror is convex. Got it? If it is concave, think that it is concave. Now, image. First, look here. It is very close to the mirror, so it is upright image. Got it? Next, I am taking it away from the mirror. Then what happens?
Inverted.
What is, if I take this as it is by decreasing the size, you can say that it is convex. And then as it is taken away from, if the image gets inverted, this is concave. Observe, object is taken away from the mirror, image. Is there any change in the size? No. Then it is always erect. Then what mirror it is?
Plane mirror.
Plane mirror.
Plane mirror.
See, this is plane mirror. Now, size will go on decreasing with upright image.
Convex.
Convex mirror, then it is
Concave mirror.
Concave
mirror.
This question was given in the examination as well. Let me read that question. Don't copy, just listen. Question you are given 3 mirrors of equal size, convex, concave, and plane. How will you identify them without touching their surfaces? Surface will not touch madbar, but how do you come to know whether it is plane mirror, whether it is convex or concave? Very simple. You have to place the object in front of the mirror and take it away from the mirror. Got it? When the object is taken away from the mirror, if the image formed is erect and having same size, then it is called
Plane
Plane
mirror.
mirror.
Plane mirror.
when the object is taken away from the reflecting surface of the mirror, if it is inverted,
Concave
Concave
mirror.
mirror.
Concave mirror.
Next, when the object is taken away from the mirror, the image is erect and get diminished.
Convex
Convex
mirror.
mirror.
This is, I have written the same question in my notes also, and even I have given the explanation as well. It is there in the page number 20. Got it? Afterwards, you can go through the material. So this is the question what I have written, and the figure we have they have given with the illustration. Illustration under you have to show with the figure. You have to give the explanation with the figure as well. Got it? And please do remember, in case of convex mirror, wherever the object may be placed, maybe between P and F, or at F, or between F and C, at C, or beyond C, image is always formed inside the mirror
Inside the mirror.
between P and F. Image is always formed inside the mirror between P and F, and also it is always erect, and the nature of the image will always be virtual and erect, size diminished, position between P and F. Artha aitana? Doubt idena? Now, shall we move on to the next part of this chapter? Next uses adella ide, but before going to those, let us go for learning the uses of concave and convex after completing the mirror concept. Now we are moving to finding the position of the object or position of the image or focal length of the mirror. So, dear students, I have already given you one information that focal length is denoted by a symbol. It is small. Object distance is always denoted by the symbol U. Image distance is denoted by the symbol
V.
V. Right? F is focal length, U is object distance, V is image distance. Then there is a relationship among these three. Relationship among focal length, object distance, and image distance.
1 by U plus 1 by V.
Given by the mirror formula. Got it? Mirror formula will give the relationship among F, U, and V. Hope that you might have gone through my notes. If
Sir,
no, you can
1
tell.
by U plus 1 by V is equal to 1 by.
Yes, it is reciprocal of focal length. That is just 1 by F. It is equal to 1 by U plus 1 by V. Okay. Reciprocal of focal length is equal to the sum of reciprocals of object distance and image distance.
Image
And this is to be read as 1 by F is equal to 1 by U plus 1 by V. This is mirror formula. Clear? And even we have some of the sign rule as well. And now, when we are taking object distance,
Cartesian plane.
distance, focal length, height of the object or height of the image, we will go for using the sign rule, which is called Cartesian sign rule. Let us come to know about those also. And before that, just write side heading, mirror formula. Side heading, mirror formula. What is mirror formula? 1 by F is equal to 1 by U plus 1 by V. What does it represent? The relationship among focal length, object distance, and image distance.
Image distance.
Right. formula. Mirror formula. It gives or it represents the relationship among object distance in bracket, right? Small u, not capital, small u, object distance, image distance is denoted by the symbol small v, capital V anta baribade. It will be considered as volume, so it should be a small v only. And next one, focal length,
Volume.
it is also smaller. Even on capital
Focus.
principal focus. Object distance u, image distance v, and focal length f. It is 1 by f is equal to 1 by u plus 1 by v. Highlight that with the box.
Indra TS, Nitin NV, Pratham GR, turn off your mute your audio. Indra TS, Pratham GR. Continue, sir.
Next, side heading, Cartesian sign conventions. Cartesian sign conventions for reflection of spherical, by reflection by spherical mirror. This was also asked in the examination. Write the Cartesian sign rule. Lens bucket illa mirror bucket. I'll tell you the question as well. First, you write the side heading. Cartesian sign rules or conventions for reflection by spherical mirrors. Whether it may be concave or convex. Spherical mirrors. Itana? ಇಲ್ಲಿ ಕಾನ್ಕೇವ್ ಮತ್ತೆ ಕಾನ್ವೆಕ್ಸ್ ಎರಡನ್ನೂ ಕೂಡ ತಾಳ್ತಾ ಇದೆ. So just draw a line and also show both concave and convex mirrors. Now tell them which mirror it is. It is
Concave, sir.
yes, and this is
Convex.
convex. And let us mark the pole, focus, and center of curvature. Here also, pole, focus, and center of curvature. Now you tell that. What does this red color line indicate?
Object.
It is object. Here also we are going to place object. Next you tell. In case of concave, where the image is formed, in this case, when the object is placed between F and C, in the image of when the beyond and is also magnified. Next, we also know that in case of concave mirror, all the images will be inverted except one.
Between P and F.
When the object
Between
is
P and F.
P and F, ಇಲ್ಲಿ ಏನಾದರೂ object ಬಂತು ಅಂದ್ರೆ ಅವಾಗ ಮಾತ್ರ image ಇರಬೇಕು. I am showing that with the dotted line. ಇದೊಂದು exception ಇದೆ. This is. And what about in case of concave, sorry, convex, where the image is formed
Behind the mirror.
behind the mirror, always between P and F. ಯಾವಾಗಲೂ ಇದೆ, and it is always diminished. Please do remember. Next, look here. What do you call this distance?
Object distance.
Object distance. Object distance is denoted by
U.
U.
Next, this is
Image distance.
image distance denoted by
T.
V.
C. This is
Image distance.
image distance denoted by
V.
Hope that you are
V.
writing. So, Hadi. Next, then what is the distance from P to F? Focal length.
Focal length.
There also you can mark. It is object distance U, image distance V, focal length F, and height of the object. No, red color is there. Height of the object. That's the num reference. Textbook ಅಲ್ಲಿ H1 H2 ಹಿಂಗ್ ಕೊಟ್ಟಿದ್ದಾರೆ, but I am giving you H0. H0 ಅಂದ್ರೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ನಿಮಗೆ. Height of the object. Then this is height of the image. HI ಅಂತ thought. HI should be written like this. ಇಲ್ಲಿ ನೋಡಿ ಹಿಂಗ್ ಬರಿಬೇಕು. ನೀವು ಈ ರೀತಿ ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ? Hi. No need to say hi. It is subscript. I should be in subscript. HI, height of the image, H0, height of the object. And this is HI, this is H0, and it is HI. Okay.
Sir, can you repeat that once again, sir?
What? Which one? Which one? Make it over. Time over.
The diagram, sir.
This ray diagram. This
Yes,
is
sir.
convex. Here, object is placed here, which is represented with the red color. Here also, image is formed. In case of concave, all the images will be inverted except in one case. When the object is placed between P and F, image will be upright. Whereas in convex, all the images will be erect only, that is upright images, and all will form inside the mirror between P and F. And object distance is denoted as U, image distance as V, focal length as F, height of the object as H0, height of the image as HI. Here we will consider 4 important distances. One is object distance, second one is image distance, third one is focal length. It
Height,
is
sir.
radius of curvature. Radius of curvature. All distance ideyala, all the distances are measured from pole of the mirror. This is the first rule first Cartesian sign rule to be remembered. All the distances, whether it may be object distance, image distance, focal length, and radius of curvature, all are measured from pole of the mirror. First point. All the distances are measured. All the distances are measured. Okay. All the distances. It may be U, V, F, and R. Distances. All the distances are measured from the pole. From the pole. All distances pole in the measurement. These sign rules are very important in solving problems. Next, second point is, this is also very important. Look here. The distances, whatever the distance we go for measuring, if the distances are measured along the direction of light, they are to be taken as positive. And in the direction opposite to the light, they are taken as negative. Right? Distances that are measured, along the direction of light or in the direction of light. In the direction of light. Are positive. And in the direction opposite to the light, are negative. Over. Finished. Come to concave mirror. What does U represent? Object distance. Okay, this is the object. Light is moving from left to right. Object distance now. Whether you go for taking from left to right or right to left.
Left to right, sir.
Right.
Light is falling on the mirror from left to right. This is the direction of light. Object distance. Whether you start from red color to this blue line or
Right to
blue
left,
line to red. Blue line to right. Because all the distances are measured from pole. Now it is in the direction opposite to the light. So
Negative.
what is object distance? It is negative. And what about here? Object distance. Light is
Positive.
one negative, ಇನ್ನೊಂದು positive. ಆ ರೀತಿ ಸುಮ್ಮನೆ blind ಆಗಿ believe ಮಾಡಬಾರದು. Object distance.
Negative, sir.
Left to right. Object is here. Then we are taking the distance from right to left. Here also negative. So object distance is negative, whether it may be in case of concave or convex. So object distance is always negative. Right. Third point. Object distance is always negative. Bracket U equal to negative. Whether it may be concave or convex mirror. Maybe concave lens, convex lens. Object distance will always be negative. Let us come across image distance. Light in both the cases, light is moving from left to right. This is the image. What is the image distance? Negative or positive? Negative. But one case, when the object is placed between P and F, image is found behind the mirror. What is the image distance here?
Positive, sir.
It is positive. It may be That is, image distance may be negative or positive in case of concave mirror. You know, in case of convex, it is image distance is here. Positive or negative?
Positive.
Positive, sir.
Direction of
Positive, sir.
light. So, image distance is always positive in case of convex. It
Convex.
may be positive or negative in case of
Concave mirror.
right. Image distance is negative, is positive or negative in concave mirror, but it is always positive in convex mirror. In bracket, right? V is equal to positive for this. It may be positive or negative. I mean, in case of concave, everything is like all the image distances are negative only, except one case. E case are matra positive. Next, come to focal length. Focal length is the distance between P and F. Alva. See, light is moving from left to right. The focal length is to be taken right to left in case of concave, whether it is positive or negative.
Negative.
It is focal length is negative. Focal length. This is light is moving from left to right. Focal length. This distance should we take from left to right or right to left? Again left to right. So focal length is to be measured in the direction of light, whether it is positive or negative.
Positive.
Positive.
Focal length of concave mirror is negative, and focal length of convex mirror is positive. Right. Focal length of concave mirror is negative. Bracket ಅಲ್ಲಿ ನೀವು F is equal to -1, and convex mirror is positive. In bracket you write F equal to positive, and the last part. Observe. Here, what does this red color indicate? Object. And height of the object is denoted as S0.
Team
These are image distances. Sorry. Height of the image is denoted as HI. Whether the image may be formed above the principal axis or below the principal axis.
Below the principal axis.
Below the principal axis.
Image may be formed above the principal axis or below the principal axis. Alva? In general, all the heights above the principal axis are taken as positive, and the heights below the principal axis are taken as
Negative.
This is another important point. In heights, whether it may be object distance or image, object height or image height, if they are above the principal axis, it is positive. Below the principal axis, negative. But object height, it is always above the principal axis. Hence, it will always be positive. Right. Last point. It is the heights above the principal axis. Above the principal axis is always positive. Always positive. And below the principal axis is always below the principal axis is always negative. Height above the principal axis is always positive. Heights below the principal axis always negative. Over. Over. Still, in tomorrow's class, we are going to solve the problems on mirror formula. Adadmele matte innond concept ide, magnification. Even that will also be discussed. And one more information for you all.
Excuse me, sir.
Key answers yesterday I could not send because as I was bit busy with my family, so that today evening key answers will be sent. Okay. Yes. With this, let us stop the class. Thank you very much. Have a wonderful day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome. Prashant sir.